Ladies and gentlemen, welcome on board Flight C2050. This is the captain, and I will assist you in a quick time travel to 2050. Our flight will be approximately 7 minutes, and will fly at an airspeed of 1,500 days per minute. The weather in 2050 is forecasted to be clear and sunny. So now, sit back, relax, and enjoy the flight. The construction industry has been living through an exciting phase of its life, growing non-stop and facing many challenges at the same time. Some of these challenges are relatively new, others are as old as the industry itself. Some of these challenges include skilled labor shortages, sustainability concerns, and a high rate of injuries during projects. But will the current situation and these challenges remain the same in 2050? We don't think so. You may ask how. Here's what we think. In 2050, every construction project will be part of a smart city. The smart city mainly refers to huge and comprehensive databases in a 4D format, which include all and every piece of information about the past, current, and future projects in cities, including all properties, such as buildings, streets, metro lines, parks, and so on. These smart databases will be updated automatically by sensors and data collection devices, which are installed all over the city, and its properties that make a digital model and a real presentation of the city in real time. They are maintained by municipalities, but are not restricted to them. In essence, these databases are part of a blockchain platform that facilitate the connection between projects and the construction practitioners based on smart algorithms to optimize the procurement process. Traditionally, every new project that is built goes through a life cycle from design to demolishing stages. Now, in smart cities, for every project, all the steps are first designed and then tracked through the aforementioned 4D databases. Accordingly, it provides the cities all of the data and information about different aspects of the new construction projects. Now, let's go through the cycle. The first notable difference in the way construction projects will be designed in 2050 will be the concept of biomimicry. Biomimicry, in simple terms, means to learn from nature to solve human challenges. For example, we can observe flights of birds and other flying mammals who have had millions of years of evolution to inform the design of their wings in the best and most efficient way possible. Then we can implement this in our own solutions, using nature as an example. The biomimicry design is already being done in some projects around the world, like the Eden project in England, and has proved to be beneficial in terms of sustainability and aesthetics. But this concept is not often used these days due to one major problem. Biomimicry designs are complex, following a complicated structure, and are hard to be construction. However, there may be new technological breakthroughs that could make it possible for most construction projects to be based on biomimicry by 2050. The first lies in the materials science domain. By 2050, almost all construction materials might be smart. The definition of a smart material is any object that has a property like its color, shape, or magnetism able to change in response to external stimulus, which could be light levels or moisture levels, temperature, pressure, or other things, so that they can reshape or construct to each other based on a given order. The second possible breakthrough is in the way that buildings are actually built. By 2050, we expect that robots will be the main labor source in the construction of most buildings. Thus, considering smart materials that can take any shape and attach without limitation, and a designer that's free to make any complicated creative design with the help of robots, we think this is a high potential. In the end, the designer will create their complete design, including all the data and 4D models of the building, in a way that the smart city databases understand, can interpret, and most importantly, can store. This information will be used in the following tasks such as procurement, construction, and many, many more. Now let's talk a bit more about procurement in 2050. The procurement will be done in a completely different way thanks to prefabricated and smart materials. Well, there are a number of constructed procurement facilities in each city. You can think of these facilities as huge materials science labs, which can produce construction elements with any shape and any specifications that are required by the designer. These facilities produce the prefabricated parts using smart materials, which, as we said, have self-assembly properties. Thus, not only are the construction materials can be of any shape, but also they can join in unusual ways without any restrictions. When the design models are sent to the smart city databases, the blockchain platform will automatically send supply orders to the facilities based on an optimized approach. Then, these orders will be processed by the robots according to the design specifications at the facilities. Finally, the prefabricated parts will be sent to the transportation section and delivered to the projects by drones. Let's take a closer look at the construction of these projects. In every construction project, there will be a central system that is responsible for communicating to the smart city. The smart city will send the construction plans to the system based on a desirable duration for the project and the budget of the project. It will decide on several things such as the number of robots needed in the project and assign a crew of robots to their tasks. At the actual construction sites, robots will get prefabricated elements from the drones and put them on planned locations. All of these robots and materials will have codes on them. They can be scanned by the robots to tell them exactly where the materials are and where they should be located for the project. Afterwards, the robots will start to build the project with these materials and the instructions received from the core database. The power of self-assembling materials will come into play as the most important part here. The self-assembling materials automatically control and connect to each other to shape connections which will make the task more easily doable by the robots. Now let's talk about the maintenance. In 2050, construction projects maintenance will be done through the Smart City. Since all the data for the projects are stored in its repository, it can track every project during its life cycle and perform regular checks and maintenance. These regular works will be done by drones and robots that are fed the data and information from the Smart City. The Smart City itself will receive the information from the sensors and data collectors that are installed in the utilities of every new building, monitoring pipes pressure, electricity, voltage, and many more. A project lifecycle will still reach the end and eventually need to be demolished. However, in the future, there won't be any construction demolishing in our sense of the word, like how we think of it today. Since all the materials used are prefabricated and smart, any refurbishment, if necessary, can be done in place. If we do want to demolish a construction for any reason, the only thing we need to do is inform the Smart City. So the designated robots can then be sent to the construction site to dismantle and return the material and elements to the facilities from which they originally came to be reused in future projects. In conclusion, we're looking at a bright future for construction. Technology is taking over the industry step by step and changing the way that projects will be carried out. The construction site of 2050 will be human-free. Robots will work in teams to build complex biomimicry structures using smart materials while minimizing rework and providing zero injuries at the sites. Virtual reality and digital models will be the main component in avoiding delays and conflicts. Elements of the building will self-assemble. Drones flying overhead will scan the site constantly, inspecting the work and using the data collected to predict and solve problems as they arise, sending instructions to the robots and the robot cranes with no need for human involvement. The projects will be in full harmony with the environment through sustainable and lean construction provided by these enhancements. All right, ladies and gentlemen, looks like we just landed at our destination. The local year is 2050 and the weather is sunny and pleasant as predicted. On behalf of our entire crew, I'd like to thank you for joining us on this trip, and we hope you've enjoyed this flight.